Yes, today let's study a numerical problem. Let's solve a numerical problem related to the basic concept of chemistry, the first chapter of the NCERT Class 11 textbook. So, let's read the question. Calculate the amount of water in gaseous form produced by combustion of 16 gram of methane. So methane is going to be burned, and we know that when methane is burned, carbon dioxide and water are formed. So after reading the question, we need to write the chemical equation. Combustion means reacting with oxygen. And the molecular formula of methane is CH4, reacting oxygen O2. It gives out carbon dioxide and water vapor as it is a hydrocarbon. Just like petrol is burned, or the gas in the kitchen is burned. It forms carbon dioxide and water vapor. All are in the gaseous state. G means in gaseous state. And after balancing the chemical equation, the reactants and the products, in accordance with the law of conservation of mass, we say that mass cannot be produced or can be created. If you are using if you are using 10 kg of the reactant, then the product will be 10 kg, provided all the reactants react. It should not be less than 10 kg or more than 10 kilogram, because you are using 10 kg of reactants. So in order to balance the mass, you need to balance the number of atoms, right? Because mass is due to the atoms. Mass is balanced, mass is conserved, means atoms are conserved. So you need to balance a chemical equation, and for that you cannot change the subscript to the formula. The subscript in the formula, that this two cannot be changed. All you can do is you put the coefficient before the molecular formula. So we have balanced this equation before. We put 2 over here, so the number of hydrogen atom becomes 4. Here are 4, and we kept one more coefficient 2 before the oxygen molecule, so the number of oxygen molecules are 4 over here. Here it is 2, and with 2 plus 2 4. So we find that the number all the atoms number of atoms are balanced. 1 atom of carbon, 4 atoms of hydrogen, 4 atoms of oxygen, right, on both the sides. So after balancing the chemical equation, now let's study. In general, it means that one molecule of methane reacts with 2 molecules of oxygen to form 1 molecule of carbon dioxide and 2 molecules of water. But what we are concerned about is we are only concerned about water in reactant and water in the product and methane in the reaction. So we only see water, methane, and water. The question says, if 16, in order to produce 16 gram, when we burn 16 gram of methane, how much water vapor will be formed? So now what we are doing is, when we burn 1 mole of methane, 2 moles of water vapor are formed, right? And converting it into its mass, that is molar mass. Methane molar mass 16 gram, water's molar mass is 18 gram. 2 times 18 gram. 1 times 16 gram. Once 16 gram. So 16 gram of, how do we get this? 16 gram means what? The molecular mass of methane is 16 U, right? Converting in the molar mass means you just write G instead of U, the unified mass, so it becomes 16 gram. Similarly, the molecular mass of water is what? 18U, 18 unified mass. So molar mass will be 18 gram. So when we burn 16 gram of methane, 36 gram of water vapor will be formed. So this is the end of the question. So the question can be asked in the other way around. They can say, with carbon dioxide, that if they say that in order to get 22 gram of carbon dioxide, how much methane is needed, right? Question can be like this. So in order to know that, we have the same balanced chemical equation. 1 mole of carbon dioxide, 1 mole of carbon dioxide means 44 gram. How do we know that? Because the molecular mass of carbon dioxide is 44U, carbon's atomic mass is 12, oxygen is 16. 16 into 2, 32. 32 plus 12 is 44. 44 U. So the molar mass is 44 gram. So now what? So what we have is like 16 gram of, in order to get 44 gram of carbon dioxide, 16 gram of methane is needed. So get 22 gram, that's half, it means 22 means half of this. We will need half of the methane, that is 8 gram, right? Half of 16 equals 8. So 8 gram of methane is needed to get 22 gram of carbon dioxide. In terms of mole, 1 mole of methane produces 1 mole of carbon dioxide, right? So for 22 gram means what? 44 gram is 1 mole, and 22 gram means half mole. 1 mole of methane produces, to get 1 mole of carbon dioxide, you need 1 mole of methane. To get half mole of carbon dioxide, you need half mole of methane, or 0.5 mole of methane. That's it.